In this video, we're going to learn about isosceles and equilateral triangles. So we want to be able to use and apply properties of both triangles. The first thing we need to be able to do is to label parts of an isosceles triangle. So the two sides that are congruent in an isosceles triangle, we call the legs. The other side we refer to as the base. The two angles attached to the base are called the base angles. And the final angle we call the vertex angle. The isosceles triangle theorem states if two sides of a triangle are congruent, then the base angles are congruent. So we just said that these are considered the legs. So if we have these two congruent legs, then we know that the base angles, so angle A and angle C, are also congruent. Using that information, we can solve this example, which says using the isosceles triangle theorem. So it says find the values of x and y. Again, if we have these two legs which are congruent, we know the base angles are also congruent. So that makes angle x 68 degrees. If you remember the triangle angle sum theorem, we know that triangles add up to be 180 degrees. So if I add the two base angles together, I would get 136 degrees. I know that triangles should be 180 degrees total, so if I subtract 136 from 180, I would get 44 degrees for angle y. The second example is very similar, so I know that these two legs are congruent, which makes my two base angles also congruent. So x and y have to be the exact same measurement. Again, I know that triangles add up to be 180 degrees, so if the vertex angle is 106, I have 74 degrees remaining. If I know that x and y are the exact same measurement, I need to divide 74 by 2 because I'm splitting it between the two angles. So each angle would be 37 degrees. In this next example, I'm finding the value of x, and I notice that the two base angles are congruent. If the two base angles are congruent, I know that the two legs would be congruent, making this an isosceles triangle. The two legs are congruent, so I would set their measurements equal to each other. So 15x plus 7 equals 23x minus 17, and then I can solve for x. So I could subtract 15x from both sides. I could add 17. I would get 24 equals 8x, and finally I would divide by 8, and x is 3. Another theorem dealing with isosceles triangles is the vertex angle bisector theorem. This theorem states if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. If I want to mark my figure, the first thing I notice is it says a line bisects the vertex angle. Remember, the vertex angle is this angle up top. If it's being bisected, that means it's cut into two equal parts, and so here are those two congruent pieces. The next thing I read is that the line is also a perpendicular bisector of the base. So there's two things that occur. The first thing I notice is perpendicular. Just a reminder, this side down here is the base. Perpendicular means that 90-degree angles are created, so I have two 90-degree angles here and here. The last part is bisector of the base. So remember, bisector means split into two congruent parts. So if the base is being split into two congruent parts, I would need to mark those two pieces congruent. This next example deals with using the vertex angle bisector theorem. So, a few things to notice. I know this is an isosceles triangle because the two legs are marked congruent. I noticed that these two angles up top are marked congruent, so I know that I'm going to use the vertex angle bisector theorem. If I want to solve for the value of x, there's a few ways I can start this, but I know that these two angles would be congruent because they're the base angles of an isosceles triangle. I also know that if this angle up top is bisected, that also means that there are 90-degree angles created by the angle bisector. Then, if I focus on using just this triangle, I have two of the three angles, and I know that angles of a triangle add up to be 180 degrees. So I have 90 plus 54, which is 144 degrees. And if I subtract that from 180, I get 36 degrees for angle x. Moving on to equilateral triangles, one thing we know is that if a triangle is equilateral, then it is also equiangular. Equilateral means that all three sides are congruent. Equiangular means that all three angles are congruent. So in this first example, it says, if triangle ABC is an equilateral triangle, find the missing sides and angles. Again, equilateral means all three sides are the exact same. Therefore, each missing side would be 15 centimeters. It also means that all three angles are the same. We know that all the angles of a triangle add up to be 180 degrees. If it's split three ways evenly, that means each angle would be 60 degrees. In our final example, it says triangle PQR is an equilateral triangle. Solve for x and y. The first thing I know for equilateral triangles is that all three sides are congruent. Notice that each side has a variable of y. We really just need to choose two of the sides to set equal. I'm personally just going to choose these two. You could have picked another set and we should still get the same answer. So 11y minus 23 equals 14y minus 59. I can add 59 to both sides. And I would get 11y plus 36 equals 14y. I can subtract 11y from both sides. I get 36 equals 3y. And finally, dividing by 3, y equals 12. For the angles, remember, I know that each angle of this triangle is congruent. I also know that each angle is 60 degrees. So to solve for x, I'm going to set 7x minus 3 equal to 60. Add 3 to both sides. 7x equals 63. And dividing by 7, I get 9.